Hi, this is Miss Weir, and this quick video will show you how to use the Aufbau diagram that we've been using in class to write electron configuration, and this chart really makes our life easier. So what you need to do when you are tasked with writing out electron configuration is you need the chart, you need a periodic table, and then we're going to apply 3 rules. Number 1, we're going to use the Aufbau principle. And this chart will really help us with that, because the Aufbau principle says that the electrons will move into orbitals with least energy first. So the less energy is on the bottom, increasing energy goes upward on our chart. So we're going to populate these in order of energy levels. And then we have 2 other rules. Number 1 is Hund's rule. Each orbital will take 1 electron first before it will take a second. And the Pauli exclusion principle, which says we have to give our electrons opposite spin. So let's get started. Our first electron configuration we're going to write is for hydrogen. And then we're going to do fluorine and manganese, but let's start easy first. Hydrogen on your periodic table has atomic number 1. So how many electrons do we have? Atomic number is 1, so we have 1 proton and 1 electron. And we're going to put this electron right here in level 1s. So level 1, orbital s, 1 electron, because hydrogen has just 1. And then when we transfer this to electron configuration notation, you're going to write down the level first, 1s, and we have 1 electron in it. So this right here is our level. This is the orbital. And then our little exponent is the number of electrons. So hydrogen is 1s1. Let's do something a little bit more challenging. Let's do fluorine. All right, look on your periodic table. What is the atomic number of fluorine? So we come over here. Atomic number is 9. So how many protons and how many electrons do we have? That's right, 9. So we need to place 9 electrons. And where are the first 2 going to go? They're going to go in 1s. And they're going to have opposite spin. So that's your Pauli principle right there. So we've accounted for 2. We have a total of 9, so we need 7 more. Where are we going to put the next 2? That's right, they're going to go in 2s. So now we've placed 4. That means we have 3 more to go. And we're going to put them in the 2p orbital. 1, 2, 3. And here you're applying Hund's rule, where you're saying each orbital will get 1 electron first before they double up. It's like bunk beds. Everybody wants to sleep on the top bunk first before the bunk beds fill up completely. So let's double check. We have 1, 2, 3, 4, 5, 6, 7 electrons. So we're good. Nope, we are not. 7 electrons, always double check. Atomic number is 9. We need 9. So we're at 7, 8, 9. So when we translate this to electron configuration notation, what do? We're just going to write down where the electrons are at. So 2 are in 1s. So the 1s has 2 electrons. 2s has 2 also. 2s, 2. Remember, level, orbital, number of electrons. Level, orbital, number of electrons. So now we have 4. And the 2p, we have how many? 1, 2, 3, 4, 5. And at the end, always double check by counting up your exponents. So you have 2 plus 2 plus 5 is 9. Atomic number is 9, so that's the electron configuration for fluorine. All right, one more example and then we're done for this video. Manganese, Mn. Find it on your periodic table. What is the atomic number for manganese? I'm going to give you a hint. Manganese is in the 4th period. 1, 2, 3, 4. Atomic number 25. All right, now I'm going to have to keep track. So I'm going to write down 25 up here. All right, we got to place 25 electrons. So the first two go into 1s, 2s, and then we're going to put 6 in 2p. Every p orbital set can hold 6. 1, 2, 3, 4, 5, 6. So that gives me 10. 2 plus 2 plus 6 is 10. 11, 12, 13, 14, 15, 16, 17, 18. So we moved from 1s to 2s to 2p to 3s to 3p. And now it's getting a little tricky because we're moving in level of increasing energy. But we don't go straight to 3D. The 4s orbital actually has a little bit lower energy than the 3D orbital. So we have to move electrons into 4s first. Haha! And now I've lost track of my electrons. So I know here we were at 10, because 2 and 2 and 6 is 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 25, so 5 more to place. And the next energy level, orbital-wise, is 3D. So 1, 2, 3, 4, 5. Alrighty, so let's write this out down in electron configuration notation. 1s has 2, 2s has 2, 2p has 6, 3s has how many? 2, 3p has 6, 4s has 2, and 3d has 5. And at the very end, I'm going to double check my math. I'm going to count up all of the exponents. So 2 and 2 and 6 is 10, 2, 8, 20, and 5 is 25.